Hello everyone, welcome back to my channel Study Desk of Anand. So in this video, we are going to see best practices used in a BigQuery. So let's get started. Now we all are familiar with the BigQuery and we are using it, but like we are avoiding a small things which are like costing higher for us. Now we know that everything in a BigQuery, whatever the query we run, right? Everything is costing us at certain level. So let's say the first best practice we can see to avoid a cost, we wanted to query to the data, right? Some table, and we want certain column. So let's say if we are using a select star, so we can see that this query cost us 3.8 MB to process this query. Now let's say our requirement is just to select only two column from this table. So instead of using select star, we can just go for this selected column only, and we can see that our cost is reduced to 1.61 MB. So with this, like we can avoid using a select star and we can go for the selected column so that our cost can be optimized. Now, next thing, let's say if we want to select the all column, but we just want to read the some years of data or some partition of data. So if we are reading from a table which are not partition, then this will cost more to us. We can see that this query is costing us 3.8 MB. We are trying to read a data where the sales is 2025, 8 and 11. Now, when we apply a partition on the same table and we query on the disk table, then we can see that the huge performance gain here now it just costing us 10.68 KB. Now earlier it was costing in 3.8 MB. Now that reduced to in KB. So that's a huge performance improvement, guys. Think of this like if you are working on a TB's data, right? And trillions of data, their partitions will be a master game changer. Like there we can save a lot of cost by just simply creating a partition on the table. Now, this is very important. The next one, we can see that many of our places where we are just cloning a table, right? Just copying a table from output to new table. Now we are having a habit of creating a table, create table, new table name as select star from existing table. So with this, we can see that if we are executing this query, so this will cost us 3.8 MB. Instead of that, if we can use a clone keyword, right? This will simply cost us nothing. Yes, you heard it correctly. This will cost nothing. It will just simply point to our existing data, and whatever operations we wanted to perform on the new table, we can easily do that. So that is really helpful in terms of cloning a data. We can use a clone keyword instead of creating a table from older approach like create table name as select star from the existing table. Now, the next best practice that we are going to see is like a filter early. So a filter early is nothing but, let's say we have certain operations for demonstration that you can see. We have a table that we auxiliary table cells we have created, and here from inner query we are just selecting star from cells, and outer query we are just selecting the inner query and we are applying filter sales channel equal to online. Now this is a bad practice. The reason being, initially this will scan entire data and the outer query will again read from the inner query and do the filtrations in the second iteration. Now, if we apply the filter early, then in the first goal, though it scan entire data, but for the second read, it will have a less data to read. So in the good example practice, we can see that we are filtering the data first that we can see, and basis on that we are just using for outer query. Now this help us improving the performance in terms of less data to be passed to the next one. Now the next performance gain we have for like materialized view. Let's say our analytic team is doing some kind of analysis, right? They are doing some aggregation operation and they are keep on hitting the query number of time. just for analysis, now just for showing the demonstrations or some other work, right? So this will cost every time like whatever the query they hit, right? So we can see that if we execute this query, this will cost us 95 byte per execution. Think of like if we have a trillions of data, the cost will be more. Now what we can do, we will just create a materialized view with the statement that aggregations has like select product and sum of amount, and this will, we can see that the performance improvement here, if we can select the query here, right? Earlier it was costing us the 95 byte. Now this is something after creation of this materialized view, this is reduced to 47 byte. Now this materialized view, for repeated aggregations, BigQuery store a pre-computed result, so the future query are lightning fast and much cheaper. Instead of pre-computing for from raw data every time, you pay less by hitting the cache memory. So this is how we can reduce a cost with the help of materialized view. Now the last one from the list, this is the bonus tips. We are having count distinct from a table, right? That we can use. So we are having habit of writing a query like select count of distinct cell ID from a data table, and we are getting, now this is a slower query and more expensive. Instead of that, BigQuery offers like approx count distinct on a sales ID. This will result the same, and this is cheaper and much faster. So I hope guys this video will help you for like improving your best practices and understand how we can reduce the cost using a BigQuery. So next time when you write a query, you appear for interview, you write any data transformation, please use this logic and make sure you pay less for writing any query. Thank you so much for watching this video. I hope this makes help. If you feel like this is uh, improving your day-to-day activity in BigQuery, please like, share, subscribe, and share with your friends. That will help me to make more such video. Thank you so much, guys. Happy learning.